Hello, Pathways class. I see a whole bunch of you signed into the Google Classroom, which is great. I think Miss Wenner said there should be about 28 of you total, and a lot of the names I recognized before, and a couple of new ones, but um, most of you I know or know of has seen around, so that's a good thing. Today I want to get started a little bit with our opening project here, and let's go ahead. If I remember correctly, Miss Wenner had discussed this golden record with you, and you did a project with her regarding sending a message out into space about the different environments here on Earth. And it's a great project. We developed this together. We thought it was a great way for both of us to start the our quarter with you. We're going to do something similar, not exactly like that, but something similar. But in case I don't know how much Winter got in the details, you remember this record was put on the outside of Voyager spacecraft to give a message to go out into space about what we're like here on Earth. And I don't know if she went over the diagrams too much, but in case she didn't, and in case you don't remember, real quick here, this is two hydrogen atoms. Usually the one electron spins around the outside, but every now and then it spins the opposite direction. And that time that it takes is the base unit for the time on here. And this distance is the base unit. So that's just what that symbol is. This is our location in the solar system. We zoom in on this a little bit here. This is where we are. These are, I believe, 14 different pulsar stars. Pulsar stars are stars that spin and give off pulses of radio waves, and they're pretty easy to find in space. This is binary code. It's dashes and dots, like zeros and ones, and that tells the frequency of each pulsar star. That's hard to say. So if you wanted to find us, this would be a good map, because you can find these pulsars, each of these, and then where they intersect, that's where we are. This shows how to set up the record, and then in binary code again, dashes, ones, and dashes. This is the time. This is to be about how long that it should take to play the record. This is the record and how fast it should rotate. It shows that you put the stylus or the needle on the outside, and how fast you should rotate it in order to get the sounds. On the other side of the record were images. Now they were embedded in sound waves, and this right here tells the person who is trying to play the record how to convert the sound waves into images. And this is pretty complicated, and so we won't get into all that. But what it basically is doing is, like, if you convert the peaks of the sound waves and the valleys of the sound waves, you will get an image. And if you do it correctly, the very first image you should get would be a circle if you decoded it properly. So that's sort of the if you remember the little information behind those diagrams. The point was to communicate with space. Now this isn't the first. Well, this was the first time. It's not the last time that we have sent things into space. We have sent radio waves out into space with an image, if you translated it, of what a person looks like, what our DNA is like. Some basic math. We have sent, let me see if I can pull that up quickly. Radio wave image. Image. Message. Let's see. See if we can find it quickly. There it is. So we sent this message out here in the form of radio waves. And this is supposed to be our DNA. This is us. I think these are the basic chemicals for life. We sent this out in a radio wave in 1974 so that we can try to communicate, because radio waves will travel very far in space. Now, another sort of vessel that was sent into space was sent recently by Elon Musk and the folks at SpaceX. And before we get to that, the reason that SpaceX has made spaceflight more affordable for more people and more companies is they can reuse their rockets. Launching things into space is very expensive because basically what happens is you take that rocket, you send it up with the payload, whatever, a satellite usually. We need satellites for cell phones, for Wi-Fi, for communications, for our Dish network and AT&T Now and the Sony PlayStation and Xbox. They all work on satellites and they have to get up there. So what happens is we shoot those satellites up in the payload, the top of the rocket. We launch the payload opens up, the satellite starts going around Earth in orbit, and it stays up there. The rocket falls back down to Earth. Now, there's a lot of time and money spent in building that rocket to get it up there, and it's a one-time use thing. It'd be kind of like you using a car to drive to the store, throwing the car away, buying another car, using it to drive to the store the next day, throwing the car away, buying another car. That's what happens with these rockets. They're a one-time use. But Elon Musk, who, among other things, created the Tesla Corporation for electric cars, he thought, if we could find a way to reuse rockets, we could make putting satellites up, putting things up, or people up into space a lot less expensive. Still expensive, but less expensive. But it is, how do you reuse a rocket? And what they did was they figured out a way to launch a rocket and then re-land it. And here's a couple of video clips of some of his rockets coming back down and re-landing. They use rocket engines here, mini ones, to try to slow it down and land that rocket. Now, that rocket could be used again to launch another satellite. That brings down the cost. They've re-landed them on land, and they've also landed them on barges out in the ocean. So there's just like a barge floating there, and the rocket comes down from space. That just launched. There's no payload on top. It came down and landed right there. Now, this whole thing could be reused, which makes it less expensive. And here comes another one. You can see the landing gear open up, and it slows down, and it can be reused. So that makes that less expensive to put satellites up. It also makes it less expensive to possibly do space tourism, I mean getting people up into space. And if you're going to get people up there, it's not like putting a satellite. You have to have a lot more supplies for oxygen and life-sustaining safety measures. So you need a heavier payload, which means you need bigger rockets. So a couple of years ago, they tested what was called the Falcon Heavy, which was these rockets here, larger ones, and 3 of them strapped together. And what they did was sent these, we'll see here, give you an idea of what it looks like. Here is the Falcon Heavy. So there's 3 rockets on the outside. 2 of them were used before, I believe, being reused, and then the payload is up here. Now, Elon Musk got a lot of crap from a lot of space people because he had never done anything in space, and they said you cannot reuse rockets, you can't get them to land. And he proved them all wrong, which I kind of like that about him. I like proving people wrong myself. And then they said, well, you certainly can't do this. You can't use 3 of these. It's way too much. And so he sent out about to prove everyone wrong again that you can do this. And what's interesting here is in this payload is not a golden record, but if you remember, he puts his own. And I'll just fast forward to this. I'd like for you to watch this video, but I'm just going to show you what he did. Oh, where is it? He put his own car in that payload. And this was his electric Tesla Roadster. Behind the passenger seat is a gentleman they called Starman. It's just a spacesuit. But what it is a prototype of the spacesuit that SpaceX was developing for space tourism for people to use in space. So he thought, well, if I'm going to put something out into space, I may as well put my car out there. It's on an orbit to go around the sun. They're thinking it should stay in orbit for at least 1 billion years. And so this is, instead of a golden record, this is his sort of message out into space that we're here and what we can accomplish. Now, there's some other things that are inside this car and on the car right here that are in the video that I won't tell you about that you can see. There's also some pretty cool, if you look at this timeline here, things that happen. Let's see if I can get it up. On this timeline, it tells you like when things are going to happen. And then these boosters coming back down as well, landing as well. So what I'd like for you to do today is watch this video. Through the beginning part here, you can fast forward a little bit to get to the explanations. Right around 6-7 minutes or so, they'll start explaining it and then go through. And then when you see these in the timeline, there's not much going on here. Go ahead and you can skip through some of this where they're just talking, and you can get to the different little bullet points here regarding different events in this test flight. So take a look at this video today, and I'll put a document in your classroom. And what I want you to do is tell me what was, not only there was the car itself, that was sort of the message out, then there was the person sitting behind the wheel, person meaning the mannequin with the spacesuit on. But what else was in the car? You may see and hear a couple of different things. So I'll put a document in, and it'll just say something like, let's say Tesla Roadster, or payload, and then I'll put what's in the payload. What was in this payload here? It was a Tesla Roadster, the mannequin, but what else was in there? Okay. All right, if you have any questions, you can send me a comment in the Google Classroom, or you can email me. And good luck. Enjoy.